Your goal while watching this video is to tell me what numbers are rational and to be able to put them in order. Okay, so first, a rational number is any number that can be written as a fraction. Okay, that's the big thing to remember. So we have integers like -3, -2, -1, 0, 1, 2, 3. Can those be written as fractions? Then they're rational. Okay, and yes, I can. All I have to do to make any of those a fraction is to put a 1 under them. All right, so all integers are rational because I can write them as fractions. Fractions, any fraction that you see, is rational because it can be written as a fraction. Duh, right? A fraction can be written as a fraction, therefore it's rational. All right, and then the last thing that's rational are some decimals. First kind of decimal that's rational is a terminating decimal. If I say I'm going to terminate someone's employment, that means basically, it's a nice way of saying fire them or end their employment. Terminate means end. So a terminating decimal is a decimal that ends. 1.5 ends, there's nothing after the 5. -0.25 ends, there's nothing after that last 5. 10.625, it ends, there's nothing after that 0.625. Decimals that end are rational because they all can be written as fractions. So 1 and 5/10. See, just wrote that as a fraction, so it's rational. -0.25 or -2500, just wrote it as a fraction, so it's rational. All right, can I write this as a fraction? If I can, it's rational. 10 and 625,000. Boom, rational. I just threw my pen across the floor. Lucky you couldn't see that, huh? All right. Then the final thing that's rational is a repeating decimal. Okay, so a decimal that repeats the same pattern over and over again, like 3, 3, 3, 3, 3, 3, 3, indefinitely, or 1, 5, 1, 5, 1, 5, 1, 5, 1, 5, 1, 5, 1, 5, indefinitely. And since I wouldn't want to put you through the stress of writing that over and over again, we can use something called bar notation or repeating bar. And we write 0.15, we put the bar over the part that repeats. So everyone else who sees it knows that that 1, 5 keeps repeating. All right, repeating decimals are rational because they also come from fractions. If you ever see a decimal that repeats, you know it comes from a fraction. For example, -1.3 repeating comes from the fraction -1 and 1/3. If you don't believe me, take 1 divided by 3 on your calculator. Guarantee you're going to get 0.33333333, right? I would like you, as proof of watching, and there's more to watch, so this isn't your only proof of watching, but in your submit box, make sure that you write for me one number that is rational. Okay, rational numbers. Writing rational numbers as decimals. We talked a little bit about this already. Write -2 and 1/4 as a decimal, okay? So here's what I would do. I would say, okay, I owe 2 and 1/4 dollars. Here's the 2 whole dollars that I owe. All right, to find the decimal part, I'm going to take 1 divided by 4. When I take 1 divided by 4, it's okay to use the calculator. I get 0.25. So -2 and 1/4 as a decimal is -2.25. The book does it another way, which also works. First, they turn their mixed number into an improper fraction. They said, okay, -2 and 1/4 is the same as -9/4. And then they just took 9 divided by 4 and made it negative and got the exact same answer as I did when I did it my way. So either way is fine. You do the way you prefer. All right, writing a decimal as a fraction. So this is the way that's really easy. Okay, we talked about this before as well. We just look and we say, okay, it starts negative, my answer is going to be negative. All right, then I look at this number after the decimal, it goes to the 100th place. So I know my fraction is going to have a denominator of 100, and I have 26 hundredths. Of course, then you can also simplify by dividing these both by 2. I get 13/50, and it's negative. I would like you, in your proof of watching, okay, to also submit the answer to this question. Write -3/5 as a decimal. Calculators are okay to use. All right, finally, this table shows the elevations of 4 sea creatures relative to sea level. Remember, sea level is 0, okay? It's where the water stops and the sky starts, 0. Which of the sea creatures are deeper than the whale? Explain. Okay, so here is the depth of the anglerfish, then the squid, here's the shark, here's the whale. We want to find which one is deeper than the whale. When we have some things in fraction form and some things in decimal form, it's really hard to compare them. So when we are comparing rational numbers, always get them all in decimal form. It's way easier than making common denominators for everything. So to compare a set of numbers, get them in decimal form. All right, so first one in decimal form, anglerfish. All right, they just did what the problem says, right? They carried out the division and said, okay, this says negative 13 divided by 10, which is negative 1.3 feet, or kilometers. In other words, the anglerfish is a whole kilometer plus a little bit extra, an extra 3/10 below sea level. Okay? Is it deeper than the whale? All right? Is a whole kilometer and even some more below sea level deeper than the whale, who's not even a full kilometer below? All right, here's 0. Here's the whale at negative 0.8, and the whale. And my anglerfish is much farther below. Okay, negative 1.3. That would be the anglerfish. Okay, check the next one. Negative 2 1/5. We could do this one of two ways. I would say, okay, I owe 2 whole dollars. Then I take 1 divided by 5 to find my decimal. Or you could turn this into an improper fraction and get negative 11/5. Negative 11 divided by 5 also gives you negative 2.2. All right, so the squid is 2 whole feet below sea level. That's really far below sea level, definitely much deeper than the whale. The squid. And my last one, the shark, when I divide out 2 divided by 11, I just get negative 0.18. So that one is barely below sea level. He's a pretty shallow swimmer. So my shark